We have the first lecture on theory of computation and automata. So first of all, we need to understand why do we need to study this subject. So this is basically a theoretical subject, but we need this subject if we want to process some textual data, and that textual data may be the natural language like English or any other language, or it may be some programming language. So if you want to write a compiler for some programming language, you will definitely need these theories. And if you want to write do some text processing for natural language, again this theory will be quite helpful for you. So in some way you can say that this course is actually the prerequisite for the compiler construction course. So this is a theoretical course, and in compiler construction you implement these theories. So the first topic that we are going to discuss in this course is regular expressions. So regular expression is a way to represent a set of words or language. So for using regular expressions, you can define some rules, and all those words which follow those rules are actually called the language for that regular expression. So before going into detail, let's discuss some symbols that we will use in the regular expression. This is a superscript static. This symbol means 0 to n. It means at least 0 and at max n numbers and entities. And then we see superscript plus sign, and this plus sign means 1 to n, means at least 1, but there is no upper limit. And similarly, a simple plus sign, and this plus sign will be like OR. So if you have a list of letters that is separated by this plus sign, it means we will choose one letter at a time from the given list of letters. So to further understand these signs and symbols, let's see some examples. Let's say you have a regular expression A with superscript plus sign. So it means, as you know, superscript plus sign means at least 1, but there is no upper limit. So all these words, all these entities are the words of this language. So at least 1 means single A, so double A is also allowed, triple A, and so on. There is no upper limit. So this regular expression represent this language, and these are the words of this language. And similarly, next we have a superscript static sign, and static means at least 0. It means null is also allowed, and there is no upper limit, so null, single A, double A, triple A, and so on. So in a way you can say, you can conclude from this that A static and A superscript plus signs are very similar to each other. The only difference is that A superscript static includes null, but A superscript plus does not include null. So we can say that A superscript plus sign is equal to A concatenated with A superscript static. So because here you can also choose null, so if you want to get rid of the null, so you make it mandatory that there will be at least single A, but there is no upper limit. So next to understand the concept of this plus sign, we see some more examples. Like here we have another regular expression A plus B. So here, as I already told you, that this plus sign means you will pick either A or B. So you will pick one letter from the given range of letters. So here, if you pick A, then the word becomes simply A, and if you pick B, then the word becomes simply B. So this regular expression can generate these two words only. So These are the words of this language. Next we see another regular expression, 1 plus 2 into a plus b. So here, as I already told, that we have to pick just one letter at a time from the given range of letters. So if we pick 1 from the first set and a from the second set, we get 1a, and if we pick 1 from the first set and b from the second set, it becomes 1b, and if we pick 2 from the first set and a from the second set, it becomes 2a, and if we pick 2 from the first set and b from the second set, it becomes 2b. So these are the words of this language. And next we have another regular expression, just for the sake of understanding, a plus b into a plus b. So here you can pick either a or b from the first set and either a or b from the second set. So the total possible combinations become, we have these 4 possible combinations: AA, AB, BA, and BB. And in the same fashion, if you have this regular expression, then you need to guess how many words are possible from this. Then you can say that you can pick, you have 2 options here, you can pick either A or B, 2 options here and 2 options here. So in total, 2 into 2 into 2, we have 8 options. So here we have, total 8 options. So, and these are those 8 options. The possible words that we can generate from this regular expression is AAA, ABA, BA, and so on. So I am giving you this example just to make you understand that how the words can be generated from the regular expression like this, that we have to pick only one letter from the given range of letters. And in this case, like if you have steric or plus sign, then if we do not have these rules, at least one or not too many. So next we have some more examples to further elaborate the concept. Let's say we have a regular expression like this, and this is a very common regular expression that you will see in your next lecture. So this regular expression literally means, you can say, any word that is possible from these 2 letters. So you can generate any word from A and B using this regular expression, including null. So how it is possible? So let's see. As we already discussed that superscript static means 0 to n. So it may be 0, it may be 1, it may be 2, it may be 3, it may be 4, 5, 6, 7, 8, and so on. So this regular expression means all these regular expressions combined. So if we assume that this static is actually 0, it means null. We are not including any letter from this range of letters, so we can generate null. And if we assume that this static can assume 1, then it means we have these 2 letters and we can generate these 2 words only. And if we assume 2 here, then it is equivalent to A plus B to A plus B, and like we saw earlier, we can generate these 4 words. And if we assume 3 here, then like we saw earlier, it is equivalent to these 3 A plus B to A plus B, A plus B, and can generate these 8 letters. Sorry, I did a typing mistake there, so I can generate these 8 letters, and so on. So from here we conclude that if you see a regular expression like this, then you can generate literally any word that is possible from the letters A and B, including null. So, and if you see A plus B whole plus sign, it is almost same thing. The only thing is that it cannot generate null. So at least you must see at least a single A or a single B, and then so it is A plus B whole plus sign is equivalent to a plus b into a plus b whole static. So this is the little introduction to regular expressions. And to further elaborate this concept, to further understand this concept, watch the next video where we will see some more examples.